Before I start off, I'll just kindly remind you that this video will not talk about the basics of second order differential equations. I'll not talk about case 1, case 2 or case 3 and things like that. I'll assume that you know all of these things, and then this video will concentrate on things that is not often discussed in classes and often come out in tests, or not often rather than sometimes, that when it comes out in tests, people may be a little don't know what to do. Alright, so if you are keen to learn on the basics of second order differential equations, I will highly recommend you to watch this video. Once you finished it, you can just come back here and check out this exam cheat codes, I would say. Yeah, so to start off with it, I would just introduce you with this question. Alright, to solve this question, normally what you would see is that there is y prime, y prime, and y. So this meaning, if I were to recap to you, if you have some understandings behind, this is just dy, d2y, dt square or whatsoever. Or in other words, this can also be rewritten as ay square minus by minus c. And I assume that you know how this is connected with this. Alright, so generally you would know that there is a, b, and c. So what can you do about it, right? Sorry, this should be plus. Yeah, and therefore the first step normally you would assume is to find the complementary function plus the particular integral, and then this whole thing is a general solution, and then with some initial condition you can solve for things. Alright, so in this video we will concentrate on the particular integral. Alright, things that is a little different from how you normally solve a particular integral. But yet I'll just solve this one first, at least you know where, just get an intuition of how I solve things. At least it might be fairly useful for you to use it in the future. So if you were to go back to the quadratic equations, minus b plus minus b square minus 4ac over 2a, alright, instead of writing over everything over 2a, I write in terms of this one. Alright, this is how I remember things, because this one will belongs to something like a case 3, if you remember, for the e rho t and then somethings. Alright, if you don't ring a bell, it's okay, because I'm not going to discuss with that, as I said earlier. But generally, the first step I will do in terms of complementary function, finding the complementary function, is to find this term b square minus 4ac, whether is it negative, so for example, b square minus 4ac, right, is it larger than 0 or equals to 0 or lesser than 0. Therefore this is case 1, this is case 2, this is case 3. This is the meaning of that, if you happen that you don't know what the hell. And then so therefore if this is this, then this is over them. If it's equals to 0, it's critically them. And if this is lesser than 0, it's under them. Alright, and I'll not go into the terms of what is under them, over them, or critically them, because I will assume that you already know what it is already. So therefore, to prove that it is this now, because I already know, we know that b is equals to minus 2, right? So minus 2 square minus 4a, a is 3, right? c is minus 1, and therefore we have 4 minus 12. Alright, 4 times 3 times minus 1 is minus 12, therefore we have 16, and therefore it's larger than 0. And this is why we prove that this is case 1. So if it's the case 1, then what we're gonna do is to just write down the complementary function. So we have aek1t plus bec2t. Alright, for some books or some text in your own textbook, this may not be a, this may not be b, this may be some numbers, this may not be k1 or k2, this may be like lambda or something like that, I don't know, but yeah, they are all the same. Alright, therefore this thing is for case 1 complementary function. Alright, and therefore to solve for this k1 and k2, what you're gonna do is to use this thing. Alright, and then just now that we know that b squared minus 4ac is equals to 16, and then minus b over 2a. We know that minus b, it's minus my b is minus 2, right? So minus 2, it's 2 over 2a. 2a is 6. Alright, maybe I shouldn't, yeah, I'll just put it here first. At least it's pretty, okay, anyway. So plus minus, square root 16 is actually 4, right? So we will have 4 divided by 6. Alright, so for k1, it's 2 over 6 plus 4 over 6, which is 6 over 6 equals to 1. If it's k2, then it's just 2 over 6 minus away 4 over 6. You would have 2 third, minus 2 6 is equals to minus 1 third. And therefore, from here we know that you can just simply rewrite this complementary function as aet, because k1 is equals to 1, right, plus be minus 1 third t. Alright, my trees. So a and b, soon if you have initial conditions, then you can solve for it. So you can just leave it as the complementary function. Alright, so after 6 minutes of what I'm just talk, if you feel that it's pretty much boring because you know that you already know all this, then let's talk about the particular integral in this case. Alright, now let's solve for the particular integral. For particular integral, this 12 function for e to the power of t, what it is CET. Alright, so if you were to differentiate one time, alright, this is when y is equal to CET. If it's dy dt or y prime, I'll just write it as y prime for simplicity sake. I'll still have back CET. Alright, if it's y dot dot, I'll have CET also, because differentiating all the way e to the power of t is always e to the power of t. It's a loop. Alright, so just simply sub it in all of this. Right? So I have 3CET minus 2CET minus CET is equals to ET. However, now this comes the tricky part now, alright? Is that 3CE minus 2CE minus CE, you will just get 0, which is not equals to ET, alright? So this 12 function is not available. I mean, this 12 function is not a good 12 function to use, alright? And therefore what we can do, instead of writing CET in this case, alright, we can rewrite as CTET, alright? So when you differentiate, you would somewhat take this t as like a extra thing that you can minus away. Later on you get what I mean. So if I were to do that, be careful that this is product rule already, because you have two terms. Alright, two terms, t is in front of another variables. Alright, so therefore if I were to do product rule, I'm just simply differentiating this one and I keep this one. So if I do that, I differentiate ct, I have c, and then I keep et, plus now I differentiate et, I keep ct, I have ct et. Alright, so as you can see, you're creating one new extra term over here. Alright, previously you are creating one new extra term over here, sorry, instead of just this one, right? So now, next, if I were to differentiate again, alright, I would have CET, because this is just differentiating, alright, plus another CET plus CTET, because we just know that this thing comes to here, right? So this thing is equals to this one also. It's just like a loop, alright? And therefore now we can just sub in all of these terms and let's see what is the final thing. Alright, so when I sub in, this is the case, and if you were to wonder what is this, is that I'm just simply subbing in this one as this two things over here, these three things I'll say. So CET plus CT, I have two CET, so this is what I wrote over here, and CTET, it's this one, alright? And then this term is simply this term, alright, because it's y dot, alright? and then this term is simply y itself. Therefore I just leave it like that. Alright, so I'm just simply rewriting this term in this form instead, but changing this thing into this thing. Alright, hope that it kind of clears you up a little bit. So if I were to expand in, meaning I multiply in all this 3 and just multiply it in, alright, you would get something like and then you have something like this, right? So let's just identify all the CTE and the CET. Alright, so I'll just simply highlight the CT one. So this is one CT, this is another CT. Okay, CT, this is just C only, alright, if you don't know what I'm talking about. And then this is another CT. So therefore, actually this one should be minus also, right? Because minus 2 multiply inside, it should be minus, right? My font, careless mistake. Anyway, so 3 CTET minus away 2 CTET minus CTET, they are all cancelling out each other. As you can see, this is just exactly what this is being done, right? Just now, they are cancelling each other. So in fact, CTET act as a form of cancelling out each other. Alright, it acts as a bait to cancel out each other, and then to help us gain this thing. Alright, and therefore if I were to take 6 CET minus 2 CET, I would have 4 CET, which is equals to ET. And from this case, then I would know that the coefficient for example 4C is equals to 1, right? Because ET cancel each other, right? So C is equals to 1/4. Alright, and therefore if you were to just sub it into your particular integral, alright, so I'll just write particular integral as equals to CTET. I'll just write it as 1/4. I would have 1/4 TET. Alright, and just to sum things up, if you remember the complementary function and the particular integral, if I were to sum them up together, this is the complementary function, this is the particular integral. And then now you are ready to solve for your initial conditions. And now I have no initial conditions, so yeah, you can just this is it. So I'm just trying to convey this thing. Alright, but just keep in mind that be very careful about this. Alright, and I shall see you soon.